Hello, and welcome to my newest video. This video is going to look a little bit different from the past videos that I've created. Putting a little bit of extra effort in to create some slides so that you as the viewer will have something to look at when I go off on little tangents, when I dive deeper into concepts. I know that my last couple of videos I'll jump into topic and then I'll start just kind of talking about it for a little while, and I feel like maybe the viewer is just sitting there looking at maybe a blank coding screen or a web page, and there's a lot of visual aspects to look at that might have nothing to do with what I'm talking about. So wanted to try to tighten this up and see how it worked. So in today's video, I will be covering an important topic that is used in every programming language I have ever used, and that is automation. In this video, you're going to see a couple things. We're going to cover a couple different sections. The first one is defining all the terms that will be used. We want to talk about what is automation and where is it used in the real world and where is it going. We want to talk about the importance of automation and why we use it. And we also want to finally jump into and say, how do we automate in Python? How do we code our programs to do tasks multiple times? And we little spoiler alert, we're going to use a for loop, a while loop, and a forever loop, and we're going to see what kind of cases those loops call for. These are the terms that we'll be using throughout the video, and you'll actually notice that they all kind of play off of each other because they're all about automation. They're almost like different ways to say the word automate. So of course the first one is the word automation, and I'm defining automation as the process of repeating a set of steps some number of times. So that is I like to think of it as repeating an algorithm, right? Repeating a set of steps over and over and over and over again, okay? That's the whole purpose of this video, is to see how to make our code repeat a set of steps. A loop is a programming term for automated set of code. I don't say, oh, I'm automating this section of my code. I just say, oh, I'm looping over my code, or I'm looping through a list, or I'm looping this number of times. I don't really say, oh, I'm automating this process, or I'm automating this section. It's just the word loop is used a lot more. And the word iterate is almost a synonym for the word loop, because to iterate is to cycle through a set, also called a loop, right? So I can say I'm going to loop through this code, I'm going to iterate through this code, or I'm going to automate this code, okay? It's all repeating, cycling a set of steps. An iteration is one complete cycle. So you'll see that when we loop something or we iterate through something, we're going to do it maybe 10 times. And for those 10 times, if I'm talking about a specific cycle of those possible 10, I'll call it an iteration. So I'll say, on this iteration, the value was, 15. And on the next iteration, the value was 16, right? So, an iteration is just a single cycle of the overall automated process. And iterable is a data structure that can be iterated upon. So if something is iterable, that means that there's multiple values in it, and that means I can cycle through each value. We'll see that here in the for loops, but we're talking about numbers, lists, dictionaries, string values, anything that's a whole number that the computer can say, okay, this, then the next, then the next one after that, then the following, a set number that we can loop through. So what is automation? We see automation all the time. I love robotics, so I'm gonna, show a couple of examples here. And obviously, robots are very automated. A lot of the processes don't have to do with the loops that we're going to talk about today, but they complete a set of steps over and over and over. And when I think about automation, I kind of think about almost perfection, doing the same amount of steps the same way each time. And so I've got these examples here. You've got the Amazon robots that are through the fulfillment centers that just go throughout the warehouse and bring, purchase items from one place to another in this automated fashion, right? There's no humans involved in this, and it just does it continuously. I also think about factories and things where you have a robot that is maybe putting a car door on, and that's its only job is to grab the car door, put it on the car, grab the car door, put it on the car, grab right, and just over and over and over. So think about repetitive tasks, things that are happening all the time. I also think about my Roomba or the Shark vacuum. Um, the same thing. It's not necessarily 100% automation. It's not this loop that we're going to be talking about, but it is doing something by itself a repeated number of times, right? So if I tell it to go clean my house, it's going to iterate each location. It's going to go through each location on its own and clean the house. Automation is one of the first tasks that the early creators of computers wanted to achieve. They realized that computers could complete a set of tasks perfectly over and over, and so it was very obvious that automation and repetitive tasks would be something that computers do very well. And if you think about it, a computer that can do math or store a value is kind of useless if it only has to do a task once. At that scale, a human can simply process the calculations or write the value down, and there's no need for the computer. One of the first times that computers and automations were used together was to collect and process the results of the 1890 US Census. The tabulation machine, designed by Herman Hollerith, used a punch hole card as input. Each hole punched was some value state and was able to process the census results in record time. All the computer had to do was repeat the task of reading the cards and outputting the collected values together. The process was much more efficient and safer as compared to humans manually reading each card, right? So if this is important, collecting all this US Census data is important, a machine can very quickly and efficiently, and I would say without fail, collect this information and process it properly. If you want to read more about it, I've got this link right here to a little article talking about the tabulation machine and the invention itself and the whole story of the 1890 US Census. It's a very famous story when it comes to computer science and learning about automation, so I wanted to make sure to throw it in there. In more modern times, actually just a couple weeks ago, this video was released. I found this video from Mark Robber channel where he built a robot that can lay domino bricks at a crazy rate. This is also automation. The video shows a robot racing a human to lay 100,000 bricks. After about 20 seconds in the video, you realize that the competition between the human and the robot is actually a complete joke because the robot is it's perfect and it moves at such a rate that the human could never work at. So definitely check out this video if this is something you're interested in seeing. It definitely goes with kind of like, those satisfying videos and engineering feats and stuff. So really cool video, really cool example of how automation is just makes productivity shoot through the roof. We're living in an age of automation. You may have heard that automation is going to take all the jobs one day. This is going to be very true in my belief. Machines are just way too good at repetitive tasks for them to not be implemented throughout the world. I mean, try to drill a screw 1,000 times and tell me they didn't make a mistake. Or try to put together 100 iPhones and tell me you didn't build an Android once. That is where the problem lies. Companies realize that computers or robots never fail at executing its instructions, where humans are flawed and we make mistakes constantly, especially when it comes to repetitive tasks. This can be the scariest future for you if you plan on growing up and working in a field overrun with automation. I see it as an exciting challenge for me to get enough skills to be one of the people automating the machines and processes. If automation can't stop, you might as well, book yourself a spot in the automated future. Hopefully, if you're here watching this video, you too want to have a place in this robot dominated world. I make my last statement with a little bit of hope and maybe a little bit of ignorance, because if you follow this link that I have here, or you do a quick online search, you'll see that companies like Microsoft, Amazon, Facebook, Google, Tesla are all working on AI systems that can actually write code for themselves. So maybe there's no job that is safe for automation, but we'll just have to wait and see on that one. In my opinion, computer science is nothing without automation. Any algorithm, task, job, or process should be easy enough for humans to complete once. If you need to send an email to a coworker, then there's no need to automate the task. You could just write the email. But if you need to write an email to your coworker every day at 2 p.m., then automation would start looking like a better option. I have a personal rule in my life. Anytime I do something more than 3 times, I start to think about how the process could be automated. I am actually trying to start another YouTube series where I document me automating my house as much as possible. Doors, windows, feeding the animals, cleaning things, all that's to be determined. So we could say that automation starts with pattern recognition. If you see a repetition in your life, then you know there's a set of rules being applied to that task. Automation is amazingly powerful, not only for the fact that we can do a task over and over again, like pulling names from PDF and putting them into a data structure, but automation also allows us to write less code. Let's see how that looks in Python. Before we take a look at what automation actually looks like in Python, let's look at a scenario. Let's say I was asked to print out "my name is Carter" 10 times. We've got 1, 2, 3, 9, 10 lines, right? That's how you would do it up to this point, not knowing what automation is. So if I hit run, you're going to see "my name is Carter" printed 10 times, okay? Now that's great, but what if it was print Carter 100 times? I mean, sure, I could copy this, start printing it all out. That could be one option, but that would take up a lot of space on my program, and it would take up a lot of time, even just copying and pasting. Because what if it wasn't 100? What if it was 1,000 or 100,000 times? That becomes a very time exhaustive task to just write out the code. That's our first test case for automation, is going to be completing a task multiple times. So if we have this print statement 10 times, we can condense this from 10 lines to just 2 lines. You can see right here, this is the for loop that I've mentioned. We're going to cover it in just a second. But if I run this code, I will get the same output as if I was doing the original. So I could even do this, and I can print, let's print no automation, and then I'll come down here and I'll print automated. Okay, so I'm going to run this again, and we'll be able to see that same result. We've got "my name" printed, "my name is Carter" printed 10 times, but one scenario took 10 lines of code and the other scenario only took 2 lines of code. So let's take a look at what the for loop actually is. The for loop is one of the most popular loops. You see it in many different programming languages, and you'll see it in Python as well, like we just saw. And for loop is a loop that is controlled by an iterable value, such as a whole number. This could be a list or a dictionary, or just some whole number that we can iterate through. Characteristics of a for loop are a known number of iterations, so that's something that makes it powerful. If you know how many times you need a task to be run, a for loop is great because you can just explicitly tell the program to run the loop that many times. Now you don't have to know exactly. That can be stored in some sort of variable or structure or list or whatever it is. But if you always needed to iterate the a specific number of times, for loop is definitely one of the best ones to work with. Now, as we just saw in the example, the for loop has some keywords and a structure that needs to be followed for the computer to understand that you're actually trying to do a for loop. And two keywords are going to be for and in. So for, iterator value, in, iterator, and then everything indented under it will be the code block that each iteration is going to cycle through. The for and the in are keywords, and the iterator value is a temporary variable. That's the iteration counter. So every time the loop triggers and we iterate once, whatever this is called, you can actually use it as a value, but it's going to have the current number iteration that this loop cycle is on. So we'll be able to take a look at that in just a second. So let me go off script a little bit because an idea kind of popped in my head as I was going over the definition of a for loop that I realized that didn't have in any of my examples. So this iterator right here, if we look here, I said the iterator underscore value. This is a temporary variable. A lot of the times I is kind of the default go-to iterator value. It's okay in some cases, obviously. In other cases, it's good if you're looping over a list of names. I would like to call the iterator name, because it's a specific name in that loop. So we could actually I'll do that later on, but I just want to show what I is. If I plug I in there, so that's going to be this value right here. I'm going to get that out of there as well. And I'm going to go ahead and run the code. And you're going to see that I is a number starting at 0. It's a whole number starting at 0, 1, 2, 3, 4. Because we told the for loop to iterate 10 times. This range method is going to make the number 10 an iterable number. So Python knows how to start at 0 and go all the way up into 10. And I, like I said, gets designated, the iterator gets designated I, but this could be pi. And obviously I'd have to change this as well, but I could run this all the same. HTG, I don't know what that made, HTG, right, there we go. Just putting random letters on there, it doesn't matter what this is called, so I can call it name if I was going through a set of names, right? And all it's going to have is the value of the iteration that I'm currently on. We're going to see when you iterate through a list that it isn't always the number. It might be a value, each value in the list that's being iterated through, but when you're using this range method, the iterator is going to be a whole number. So one of the tools I like to use when teaching about automation is the turtle module, and this is just a basic visualization tool where you control a pen using some built-in commands. It's still all Python, but we're working with this turtle module. So basically all the commands you see here are a part of the turtle tool, and but the concept is still the same. So what I want to do is I want to make my turtle or my pen object draw a square. Now if you think about it for a second, how is a square going to be drawn? I need to go forward, make a 90-degree turn, go forward, make a 90-degree turn, forward 90 degree, and forward, and then another 90-degree turn, right? So there's 4 repeated patterns, right? Or there's one pattern repeated 4 times. Forward turn, forward turn, forward turn, and forward turn, okay? So I'm gonna run this real quick and let's see. So click on this guy. I've got it going pretty slow so you can see the pattern because I have to switch windows. So that's what it looks like. Let's take a look at what it looks like using a for loop, right? Because we know the number of iterations that we need to make a box. We can take a look at example 2b, and relatively same code. We're going to import the turtle module tool. We're going to create a screen object, set the speed, color, and then right here you can see this is our box, right? For side in range 4. So we're going to loop 4 times. We're going to go forward and we're going to turn left 90 degrees. Same exact thing as we did up here, just a lot less code, right? Everything is condensed down to 3 lines, as opposed to, I think, 8 lines or so. 1, 2, 3, 4, 5, 6, 7, yeah, 8, because 4 times 2. And I'm gonna run this code, and we will see the same exact thing. So we're gonna make go forward, make a 90 degree, forward, and 90 degree, and it happens 4 times. So that's a cool thing about the for loop, is I know exactly how many times I want to run the code, how many times I need to iterate exactly, and so the for loop is the perfect tool for us. Again, here's another example using the turtle module, and this time we're going to be making a triangle, and same thing with the square. I know exactly how many sides a triangle has, so I know exactly how many iterations I'm going to need. That means that the for loop is the perfect automation tool for the task, because I can just simply tell the for loop to run 3 times, do the commands, which would this time be forward and then a turn of 120 degrees, and from there I make a triangle. I'm going to slow this down, set the speed of the turtle, because I think when I ran it, it went super fast. So we're gonna run, and I'm gonna click on this, and you can see that we're going to do this 3 times. We're gonna go forward, we're gonna make a 120 degree turn, forward, forward, and then turn, just because that's how the pattern goes. So this example is a little bit different. I did mention it just a moment ago, and this time we're going to be iterating through an object. We're not just going to be iterating through a whole number. We're going to tell the for loop that we want to iterate over every value in this list. And now I know we haven't covered lists extensively. I will make a video on that, but just know that a list is a set of values, okay? And when I want to use a for loop on it, rather than saying for element, list item in range list item, I just say list o names. For name in list o names, which is my list, I'm just saying iterate through this list here, and the iterator name is going to be each value. Actually, I can do this real quick. Let's go ahead and comment this out, and let's just print the iterator, because remember when we did up here, when I iterated through this, let's make that I, when I iterated through I, remember it was 0 through 9, it was an actual whole number value as the iterator. This time, when I iterate through this list directly, each value is going to be the names in the list. So if I run this, you can see that we've got all the names in the list is each iteration, which is really helpful if I want to, like you're going to see in this example. Let's just break right into it rather than me talking about it. I'm going to iterate through the list, and all I'm doing is I'm trying to find the name Carter within the list. Okay, so I can obviously see where the name is, but again, think about if this was a list of 1,000 names or whatever. I could say for name in list of names, and then if the name equals Carter, right, depending on the iteration, the first time through, name is going to be Bob. It's going to say if Bob equals Carter. Well, that's false. So we're going to continue. And then the next iteration through, name is going to equal Kevin, and we're going to check. Actually, let's go ahead and keep that print so we can keep a track of how many names we iterated through before we found when name was Carter, which is going to be the 5th iteration. So I'm going to hit run. You can see Bob, Kevin, Madison, Kelly, Carter. So once name was Carter, this statement was true. We printed Carter in list, and then we used the break keyword. And that's another note we should make. If you ever want a loop to stop, you use this break keyword, and this break keyword is going to look up in scope, and it's going to say, okay, well, what is the closest for loop or the closest loop to this statement, and that's going to be this for loop. So when the computer reads this break statement, it's going to continue out. It's going to leave the loop. Doesn't matter if it's on this iteration, the first iteration, the last iteration, it doesn't matter. Once the computer sees this break statement, it leaves the loop. And the opposite would be this continue statement. So continue is a keyword in Python. And when Python sees the continue, it knows that it's not going to be looking for any other code. I don't necessarily know the actual value of the continue statement. I know that for me, it helps me visually see what's going on. Because if I just had else, or if I just had nothing, that would be okay too. But I just like to put that there so that when I read my loops, I say, okay, well, I'm looking for this. And if nothing else happens, we're going to continue the loop. The only condition that's going to stop this loop is either we finish or we get the correct value that we're looking for. This example is very similar to the one that we just saw, where we're looping through list of names and we're trying to find the value of Carter. This time the iterator is different. So in the last example, we were iterating directly over the list. So the iterator's value was Bob, Kevin, Madison, right? It was each value in the list. Now we're using a different method called len, or length. Not entirely sure if we've used it in any of my past videos, but len stands for length. So if we put it on a string or we put it on a list, it's going to tell us the length of that object. So you can see that we have list of names wrapped in this len object. So this is going to return a whole number. It's going to return 2, 4, 6, 7. It's going to return 7, and then we're going to also again wrap it in this range method, right? So for name in range, the length of list o names, right? So we're using the len method to get the length of our list, and we're turning it into an iterable number that we can then use in our for loop, okay? But this time, again, let's do this. This is where it gets kind of confusing when I start teaching about this. I've seen before. In the last example, here, I'm going to keep that there, but I'm going to keep that like this. And I'm going to print loop through values. And then here, I'm going to say loop through length. Okay. So when I run this, you're going to see that this kind of loop where I'm saying for name in list o names, name is going to be the actual values of each item in the list. In this case, where we're using the length of the list to iterate through, name is now again a whole number. So rather than Bob, Kevin, Madison, it's 0, 1, 2, 3. So I'm going to go ahead and run it, and you'll see both outputs. Let me open this up. So you can see loop through values. We get Bob, Kevin, Madison, Kelly, Carter. And again, that was the first loop that we were just working with in the last example. And then we have loop through length, and we have 7 values because our list is 7 values long. So let me go ahead and re-comment this out, and now I will go ahead and uncomment this whole thing. So then when you're working with looping through the list's length, you have to remember that your iterator is a number, and rather than working directly with the element value, you're going to have to index the list. You're gonna have to say, give me item n, right? Name is gonna be some number. Let's say it's 2. So give me the second element in the list of names and check if it is equal to Carter, right? Again, same thing we're doing from the last example, but this time our iterator is a number rather than a actual value of the list. So I'm going to go ahead and run this, And you can see Carter in list at position 4. That's great English. But I am 0, 1, 2, 3, 4, right? We start counting at 0. This number is always going to start at 0 and move its way up. Now that we've done a few examples with the for loop and you can understand that the for loop is an automation tool that it works off of a known value of iterations, we're going to take a look at the while loop, which is a conditional based loop that continues to go while a condition is of a certain state. Okay, so a while loop is a loop that is controlled by a conditional statement, true false statement, right? So if something is true, keep going. If something is false, keep going, right? Keep looping until the condition is the correct value that we're looking for. The characteristics of the while loop are that it's good at an unknown number of iterations. It is good for iterating until something happens in the code. I like to use while loops for user input. So if I'm looking for a specific range, like maybe I tell the user to input some number between 1 and 10, the while loop is great for saying, well, keep asking the user for the input while the input is not within range. Okay, so we'll actually see one of those examples here in a moment. And the third characteristic is that a while loop requires manual creation of a counter or a controller. So in the for loop, we have for I in range, or for I in range length of a list, or for name in list of names. The iterator is already created. In a while loop, you have to create an iterator, or especially if you want it to run a specific number of times. Now, if you're trying to work it off of a condition, there has to be a condition created to make the while loop work properly. Here's the structure of a while loop. And like a for loop, you have a keyword. This one is while. So while, true false condition, do code. Whatever it is, we're going to see how it actually looks in the Python code right now. So here we are. Here are the examples, and the first thing I wanted to do is I wanted to show you how to do the same thing the basic for loop does, like we saw. For I in range 10, print I, right? That's going to print out, we're going to say this is the for loop, while loop. Okay, so we're going to run, and then we'll take a look at what the code does. We can achieve the same thing in a for loop as we can in a while loop. Okay, so it really comes down to which tool you want to choose. There are better conditions for each. Like the for loop, we know the number of iterations. While loop, we can go while a condition is of a certain state, but they can achieve the same things. It is a little bit different though. So you can see, again, we have to create the counter or the iterator in this while loop. And you can see we create a variable called counter. We set it to 0, or we'll set it to some value. And then we'll basically say while counter is less than 10, print counter, right? This could be any code out there. And then we need to manually increment the counter variable. So we're going to say increase by 1 each time. That's all that the for loop is actually doing, but it's doing it on the back end, and we don't have to explicitly write that code. But you can write that code when you use a while loop. So we have counter equals 0, and while counter is less than 10, we're going to do our code, and then we're going to increase the value. Now, we could, set this to 4, and then we could run this code, and we'll see that, we have a limited number of times. It's going to be 5 more times, but it's still possible to iterate over a set of values. Now, something we want to talk about with the while loop, and we're going to get into this in just a second, but if I remove this, when is the loop going to stop if I'm not incrementing? So let me go back. What I just removed was this line of code, counter plus equals 1. So this would add 1 to our counter variable or our iterator. If I remove this, when is counter going to be greater? When is this statement going to be false? Because right now it's true, right? 4 is less than 10. When will the counter variable make this statement not true? Let's see what happens if I run the code. So you can see that we get stuck in an endless loop, what I like to call a forever loop. This is an error. A forever loop is something that can be used purposefully, which again we'll see here in a moment. But for our case that we're looking at currently, this is an error. This is a bug in our code because we didn't give our computer, or we didn't give our program an instance or the ability to leave the loop. It's just going to be stuck at 4 because we're never adding any value to our counter. Now again, I could stop in here. I could say counter plus equals 2, right? So we could go from 4 to 6 to 8 to 10. So it's only going to loop 3 times, right? Because on the 4th time, we're at 10. So 10 is not less than 10, right? So that statement is no longer true, and the loop kicks out, and it would leave, right? It would continue on with the next process or the end of the program. So here's a quick example that I threw in there after making a mention of it in the slide. I like to use while loops for user input verification. And if you think about it kind of in an abstract way, it's got the same structure as the last example where we have some iterator, some state, some value that we are going to evaluate as a conditional, and the while loop, and then the code inside of it. So let's run that back. We've got a iterator or a condition that our loop is going to evaluate, right? While user in is not blue and user in is not green. So I'm going to force the user to input blue or green as the value. Any other value that's not blue or green is going to kick us back into the loop and attempt to get user input. So if I run this, let's try this. So what is your favorite color? My favorite color is red. No. What is your favorite color? Yellow. What color is better? I'm gonna say blue. Blue is better. So once I put the correct input and this condition is no longer true, then it breaks out and we continue on with the program. So this little line right here is really fun to do when you're doing little text-based programs and you want to verify that the input that the user is inputting is of the correct type. With a number, it's a little bit different, but I'm not going to go into that because I've got a ton of other examples of while loops that I want to get into. This setup is a little bit similar to what we just saw, but I actually use this structure for when I'm making a menu. Sometimes in a program, if I'm trying to make like a calculator application and my program has, 5 different things. I can do addition, subtraction, multiplication, division, rounding. I want a menu to pop up with all those options, and I want the user to choose one of the options, and then when they're done with that and the operation takes place, I want the menu to pop up if the user wants it to happen. So that's kind of what we're doing here is I've got, I've this little iterator, this little conditional that is called trigger, and it's got no value. It's just an empty string. And I'm saying while trigger is not equal to stop, we're going to continue on with this loop, right? So we're going to get user input. We're going to ask them, do you wish to stop the program? Yes or no. And if the user input is check, I could probably change this to user in. It's a pretty good go-to value. If the user input is yes or no, y or n, right? I'm saying if user input is y, then the trigger is now stop. And if the trigger is stop, then this statement is no longer true, right? Because stop not equal stop, that's a false statement. So once trigger gets turned to stop, then the loop will finish, and we can run this. Again, you're gonna see that the while loop is nice to make kind of like a gatekeeping. or continuation of your code. So do you wish to stop the program? No. Random text output, here's where the rest of your code would go. Do you wish to stop the program? Yes, I do wish to stop the program. Actually, no, let's say no again. Let's say no again. And now we'll say yes, we want to stop the program. And you can see stop the program outside a loop. So we're going to bring it back to the turtle object that we were looking at in the beginning, that turtle module that made the square and the triangle. And this time we're going to implement it in a while loop. This one is a little bit different. You can actually find this example on the turtle documentation page, which I highly recommend anyone go to and kind of dabble around with it. We've got our setup, right? So we don't have to worry about this and we don't have to worry about this. But right here we have our actual loop. And this says while true, forward 200, left 170. And then it says if absolute position, this is the position of the pen, is less than 1 relative to where it started, then we're going to use that break statement and we're going to break out of the loop. Now, this is a forever loop that we mentioned earlier. And earlier I said if your code has a forever loop, then that means you have a bug in your code. But this is an example where the forever loop is okay because we don't want to have to calculate how many times we want this to run, but we want to say keep it running until the pen reaches the same position that it started. And of course, that the person who created this code knew that the pen would end back up where it started because you could, potentially it could land somewhere else and then it would go on forever. But they knew that, so they said once it gets to the position where it started, break the loop. So break the forever loop because this is a forever loop while true, because if the while loop evaluates some conditional statement, you can see that true is never going to be false. So this statement is always going to produce another iteration of the loop. So let's go ahead and run this real quick. And you can see that we have this crazy star thing that kind of looks like a sun, and then it fills with color, which I just realized that I forgot the end fill on my triangle and my square that I made. But you can see that the let's run it one more time. It's pretty cool little code, kind of a classic turtle file program that you can run and see some cool stuff that it does. And that's a thing with the while loop. We can even let's slow it down just so we can see what's happening. There we go. So it's going forward and it's turning 170 degrees, going forward, turning 170 degrees, going forward, turning 170 degrees, and it's just going to keep doing that until it reaches the position where it started, which is right here. Now, I'm not going to watch it go all the way through at this speed, so I just wanted to show there's your pattern. Turn, forward, and turn, forward, and turn. So actually, this is really only a couple lines of code, right? This is 5 lines of code, and you make something pretty cool with just 5 lines of code. The next example that I'm going to show you is a little bit more complex. There's definitely a little bit more code, so if you need a moment, just pause the video and rewrite the code on your own to take a better understanding of what you're doing. And you should always definitely be writing the code that you see on the screen. It's the number one way to learn how to program. You can listen to me talk all day, but actually writing it is super important. So these are functions. They're just little blocks of code that are isolated that I can call multiple times. I'm going to have a video on functions here pretty soon, so don't worry too much on them. But what this program is doing is playing a game called Fizz Buzz. And it's, again, a pretty standard first programming activity is to program Fizz Buzz. So all it is a game that you input a number, and the program is going to loop through each number from 0 to the number that you inputted, and it's going to return the number, or it's going to return the word fizz, the word buzz or the word fizz buzz. And it's going to return the word fizz if the number is divisible by 3. It's going to return the word buzz if the number is divisible by 5. And it's going to return the word fizz buzz if the number is divisible by 3 and 5 together. So that's all this does. This function is going to determine if the number is divisible by 3. You can see if num is divisible by 3, divided by 3 has no remainder, return true. And same thing for buzz. If the remainder of number divided by 5 is 0, return true for buzz. Now, if we look at the code, I've got 2 loops going on here. So this is a little bit more, in-depth look at what you can do with loops inside of a program. And the first loop that we have is a forever loop. So this is one of those times when using a forever loop is a great option, because I want the user to be able to play the game until they decide they don't want to play anymore. So we have a while true loop, and you can see continue check equals input, would you like to play fizz buzz, yes or no? And if the input is yes, then we go into the game itself. And if the input is not yes, then the program says maybe later, and we use the break statement to break the loop. So as long as we keep inputting yes, the forever loop will stay true, and will continue on playing the game. Now, the second loop that we have is after the user has said that they want to play, right? They've inputted Y. It says, okay, let's play. And the program is going to ask the user to input a number value. Now, I don't have any sort of checks in place to make sure that the user actually does put a number value in, but I'm the only one playing it, so I'm just going to pretend like there are. And what happens once this number is inputted, we're going to use it in a for loop. I'm going to say for iter number in range my number, the user input number. Actually, I'm going to change again. I'm going to say user in, because I like using that. Lets the person know what that is. So user input, we're going to say for iter number, for iterator number in range user input. We're going to store 2 values, the value of fizz and the value of buzz. So that's going to be either true or false, and true or false, right? These are calling those functions that we just mentioned. Again, not a big deal. These are either going to be true or false, whether the iterator number is meets fizz and or meets buzz and or meets both of them. So the program then for each iteration is going to use this number to determine if it should print fizz buzz if both my fizz and my buzz are true, just fizz if just my fizz is true, and buzz if my buzz is true. Else, if neither fizz nor buzz are true, then we're just going to print out the number. Okay, a little more complex than the basic examples that we've been doing, but it's pretty easy. Again, take a moment, pause this video, write this code down, and see how it works for yourself. That's always the best way to do it. So I'm just going to run main here, and you can see we're inside of our forever loop, right? We jumped inside of here. We're at this statement right here. Would you like to play fizz buzz? Yes, I would like to play fizz buzz. Okay, let's play. Well, please enter a positive int. I'm going to enter 16. And here we go. So 0 is fizz buzz. I should have written some code that doesn't allow 0 in there, but my bad. 1, not divisible by 3 or 5. 2, not divisible by 3 or 5. 3 is divisible by 3, so get the output of fizz. 4, nothing. 5, divisible by 5. 6, divisible by 3. 7, 8, 9, divisible by 3. 10, divisible by 5. 12, divisible by 3. And 15, divisible by 3 and 5. So you get fizz buzz on that one, okay? So I'm just going to terminate that program. Oh, actually, no, I don't want to terminate it. I want to run it again so I can show you that I want to play. So we're going to put yes, and then again, I'm going to put 16. We're going to get this output. And then again, look, we're back here at the top of our program. We are back at line 175 right here. Would you like to play FizzBuzz? Yes or no? We're still inside the forever loop. If I choose yes, then it will say, okay, we'll put in another number. Put in 25 and some, the game plays. And then, would you like to play FizzBuzz? I'm going to say no this time. It says maybe later, and then the program exits. Okay, so continue check was not Y for yes, so we went into maybe later and break statement, and the program ends. And finally, the last example we're going to look at is a small algorithm called the bubble sort. Now, again, we haven't talked about lists, but we're just going to show you what this looks like. A bubble sort is going to sort all the values in this list and bring the highest values to the front, and it's going to sort the list in order of greatest to least, okay? And the cool thing that we should be focusing on is this right here, for I in range length of our list, for k in range I. So what we're doing, this is called a nested for loop, and that means there's a for loop within a for loop. Okay, this is a little dangerous because program can exponentially slow down as the list gets longer, but what we're dealing with right now is not too bad. I just want to show what this looks like. So we have a for loop within a for loop, and what it's going to do is, right, this is going to start at 0 always, right? It's going to start at the length of this list. Let's say this value is 20. I'm not entirely sure. So it's going to go 0 to 19. So when it's 0, it's going to be 4k in range 0, and then it's going to do this code, and then this iteration is going to be complete. So all this code is within one iteration of I. So when I is 1, it'll be 4k in range I, 4k in range 1. And then it will run, then this loop will run through its iteration, which is all a part of this larger loop. This is called a nested for loop because you have a for loop nested inside of another for loop. So I'm not going to dive too deep into it. You can pause this program and take a look at how this works. Really all it does is it takes a look at the value or the list element at position I, and it sees if the list value at position K is less than that. And what it does is it swaps those values. Again, pretty standard sorting algorithm. It's very low end, it's not complex, and it's very slow, but I just wanted to show the double for loop. So what you're going to see is a lot of output, and you're going to see that this list gets sorted one piece at a time. So it happens very quickly, but I can somewhat bring this up here, and if I actually scroll through it pretty quickly, you can see the values changing. I like to do that. I like to scroll through, and you can see, oh, look at all the values like shifting one piece at a time. So at first we have a super unorganized list, and then over time the well, actually, this is when I is 0. Actually, you know what we should do? Here's what I'm going to do. I'm going to print, you know what? We're going to take this whole example and we're going to throw it in the trash. I'm going to say for I in range, I'm going to say 100, let's just say 20. And then I'm going to say 4k in range I. Then here, I want to print, this is going to be a lot cleaner for us to see. I'm going to say k, and then I'm going to put the value of k in there. So you're going to see that for every iteration, I is going to start at 0, and then k is only going to go up to 0. And then that iteration is going to, this loop iteration is going to be finished, I is going to become 1, and then k's max number is going to become 1. And then I is going to become 2, and then k is going to loop all the way up to 2. And then I is going to become 3, and k is going to loop up to 3, okay? A little bit, hopefully this is a little, I thought maybe doing that, but once I started talking about the algorithm and the sorting and the list and all the things, it's just a little bit too complicated to do, and this video is already getting super long, so I'm just going to do this and you can take a look at it. So when I is 0, k doesn't even get to iterate because the loop doesn't even happen. When I is 1, k can go up to 0, but then once it gets to 1, it finishes. Same thing. I is 2, you've got k, 0, and 1. When I is 3, you've got k 2 through 0. When I is 4, you've got k 3 to 0. When I is 5, so you're always, whatever I is, k is going to iterate as if it's going to iterate up into the value of I, okay? So when I is 8, k iterates up to 7. If we go down here, when I is 11, k iterates up to 10. This is a little bit more complicated, but I would definitely just give it a try. And I really use the print statement, and you can even use the turtle tool to add some visual aspects to the nested for loop. So that was the end of this video. Thank you so much for making it to the end. If you've made it to the end, congratulations. You now know everything that I know about for loops and while loops. Maybe I definitely know a lot more about while loops and for loops, but I'm pretty sure that this is going to be one of my longest videos yet, but that's okay because I don't really care. So if you enjoy watching it, again, thank you so much for watching it. If you didn't enjoy watching it, let me know what I can do to do better, maybe presenting different. But I do thank you for watching this entire video. And now we're going to sit back and relax and listen to the outro music that my boy Riley made for me. So let's listen.